A solid cylinder rolls along a surface. The hoop has a mass of 4 kg and a radius of 3 meters. It has a translational velocity of 8 meters per second. What is its total kinetic energy? Same thing here. Derive translational kinetic energy. You get 1/2 meters per, no, 1/2 mass times velocity squared. You add that with the rotational kinetic energy, you get 1/2 inertia times omega, which is angular velocity squared. You have now this equation. Then you realize that because they don't state the omega in this problem, you need to derive omega, which is going to be velocity over the radius. It can be little r, it doesn't matter, just the radius. Just know that it's the radius, and then realize that we're working with a solid cylinder. So remember how in last video we were working with a hollow hoop, which has inertia as mr squared. For solid cylinder, the inertia is going to be 1/2 mr squared. So 1/2 mr squared for inertia. And just so you know, for a sphere, it's 2/5 mr squared. Okay? Again, if you know these three, you're good to go. Moving on. So let's remove this. Rewrite this. Plugging this in for I and this in for W, you get total kinetic energy is equaling to 1/2 mass times velocity squared plus 1/2 inertia for a solid cylinder, which is mr squared times vr squared. Big R, little r, doesn't matter. Okay. Now, distribute the 2 for both v and r. You get UK total equaling to 1/2 mv squared plus 1/2 times 1/2 mr squared. You get v squared over r squared. Okay, this same thing as this. Then you cancel out the r squareds. You get UK total equaling to 1/2 mv squared plus 1/2 times 1/2 is 1/4 m v squared. All right. Again, fun part. We will erase these. We know that m is equal to 3. No, m is equal to, mass is 4 kg. Radius is equal to 3 meters. And translational velocity is equal to 8 meters per second. Plug and chug. You get UK total equaling to 1/2 mass, which is 4, times velocity, which is 8, plus 1/4 mass, which is 4, times velocity, which is 8 squared. Then whip out a calculator. You get 1/2 times 4 times 8 squared plus 1/4 times 4 times 8 squared. You get 192. Therefore, (192 joules is the total kinetic energy for a solid cylinder to roll along a surface.